Hello. In the last video we showed that the gradient of the curve y equals x squared at a point x equals 3, y equals 9, that the gradient was 6. In this video we're going to generalize that result for all points on the y equals x squared curve. Okay. So as we did before, we've got our curve, that's the green line here, green curve. And if we start at a point, but here we're going to start at the point x, and therefore our y value is x squared, isn't it? And we're going to move along a little distance, little h, yeah? So the upper point in our triangle here on the curve is x plus h, and therefore the y value is x plus h squared. So if we're going to move on and find our gradient, well, we know what up it, as our long is h. Now we need to find our up value. So the change in the up, going up, is the difference in our y values. And for the upper point, our y value is x plus h squared, and for the lower point, our value is x squared. If we expand this bracket here, using the grid method, we can find that that is x squared plus 2xh plus h squared. And then we're going to take away our x squared at the end. So effectively that cancels out those two numbers there, doesn't it? Yeah, those two cancel out, as happens quite a lot in the maths we're going to see. So therefore we're left with this expression 2xh plus h squared. So that's going to be our up. And our gradient, definition of our gradient is up over along. That's our change in y over our change in x. Well, we've got our expression for the up, and we're dividing it by our expression for the along, which is just h. So the first term is 2xh here, divided by h is just 2x. And our second term, h squared divided by h, gives us h. Now, as with what we did before, we want this triangle to be really small. So h is getting smaller and smaller and smaller and smaller and smaller. And in practice, that means that h equals 0. And if we put h equals 0 into the expression here, well, that remains, the first term remains 2x, and the second term is 0. Yeah. So our gradient now becomes 2x. Yeah. So for the curve y equals x squared, the gradient at any point of value x, the gradient's going to be 2x. So the example we did before, x equals 3, therefore the gradient at that point is 2 times 3 is 6, which is what we found, isn't it? And if we were x equals 2, then the gradient would be 2 times 2 would give us 4. And if we were at the point that x equals minus 2 on the left hand side of this curve, left hand side of the axis, then x equals minus 2, then minus 2 times 2 is minus 4. And if we were x equals minus 3, we'd be at minus 3 times 2 is minus 6. So this method here does help us to work out the value of the gradient generally at any point on the curve. So can you see that we could use this method for any curve? But here we've proved to ourselves in the first instance that for y equals x squared, then the gradient m at any point is 2x. I'll leave it there and come back to this in the next video and expand it further.